So let's get started. Last presentation of the day. Thank you everyone for being here. I will be talking about not as technical as the previous presentation, going into spin locks and SMP and so on, yeah. But there are like a few interesting things that I will be showing. So it's not only, general graphs, etc. It's going to go a little bit technical, yeah. Basically, we have been collecting data and tracking data in Zephyr for a while, actually since the project has started. I mean, when it was started eight years ago, the first thing we would start, counting, looking at commits and looking how many boards were added last month. Started with 8, or like a handful of boards. There were obviously we also had a few drivers, and that started growing as well. So these are like the type of things we were tracking, and that was mostly, to see if we are like healthy, if things are going well, and 8 years later, which is basically this year or today, we basically established like constant growth in all of these areas, like commits, like number of boards, like drivers, hardware supported, and or architecture supported, and so on. And recently, or in the last few years, we started also tracking all kinds of things that go beyond the obvious metrics, like commits and number of boards. We started looking at things like, metrics that are related to project health, performance metrics, KPIs, key performance indicators, talking about performance here, footprint, and so on. And other metrics that in many ways keep us honest toward our community, yeah? Trying to track like, how long it takes for something to get merged, the review times, how long does it take for an issue, to get resolved, and so on. So all kinds of things that helped us also improve, our performance as an open source project, but also keeping like to the promise with which the project has started, which included something like, constrained devices and minimal footprint and running on different architectures and so on. So when tracking metrics and you can go really wild in the things that you can show and display. So you can go, about issues, about how many forks and how many stars you have on GitHub, how many downloads. Although, downloads doesn't really apply in our case. The documentation and how it evolves, how many organizations or users are using Zephyr, number of contributors, etc., right? There are so many metrics and so many key items that you would use to track an open source project and see if you are healthy. I will focus a little bit on the technical side, not on the social side of things. And I will be showing, have a few use cases or a few things that we are tracking, show basically how we have been doing over time, and also, how we are using this data and how we are reacting to this data. So the things that over time we have identified is that obviously, there is constant growth. I talked about that in the community. The code base itself and hardware support, and also the use cases of Zephyr in terms of like where it is being used, the different features that it supports, and so on. We're also using some of the metrics that I will be showing. You will also see that it is, easy to say that, or it is fair to say that we have a stable core of the OS. There are a lot of fluctuations here and there, but things that are manageable and things that are usually expected. And it's not always going in the negative side. We actually have very good improvements over time. I will show a few of them. Some of them would be familiar because they would correlate like to key events in the tree. And it's very easy to identify and see and understand also why these things are happening. So metrics are not always there to show you that you are doing something wrong. They actually show you sometimes that, hey, you are on the good path and you are doing something right. So let's start with a few case studies and a few examples of things that we have been, of data that we have been tracking. So the first one is a little bit social, but it's a very, important metric in my opinion, and something that, depending where you are looking, you get different numbers, right? I mean, it's a matter of definition at the end of the day. So if you look like, for example, on GitHub, you will see that we have like 2,000, that's what, like one of the numbers you will see, 2,039 contributors, according to GitHub. And that number basically means that since the project was started based on the code base and how many commits you have there and who has committed, we have over 2,000 contributors. Obviously, that does not mean that at any given time we have 2,000 contributors, but over the life of the project, over 2,000 people actually worked on the project, contributed in one way or another. In this case, it's going to be a commit. Somebody committed something. If you look at Git, it's a little bit more because the project goes actually beyond GitHub and before GitHub, and there are probably a lot of commits in the tree for users who actually don't have an account on GitHub or there is now, GitHub can't find who that is, etc. So it's a little bit more, and if you attended my session last year, and some of you probably did, the history of our project goes beyond or before it was posted to GitHub, a few years before and maybe more years before it actually was planned to go and become Zephyr. So this is according to GitHub. If you look at the Linux Foundation, I have actually all the links for some of these dashboards and areas also linked at the end. There is a dashboard like with a lot of metrics from the Linux Foundation that tracks various projects managed by the Linux Foundation. And Zephyr is one of them. And there, basically, the number of contributors is tracked as over 6,000. And that's due to the fact that contributors are considered anybody who has touched or did anything on GitHub. So you can actually be submitting an issue or editing a wiki probably, or doing whatever. You are considered a contributor, which is fair, right? That's where like contributors sometimes the terminology is a little bit confusing. So I think that contributor, anybody, you don't have to be committing code. You might actually be just participating in meetings and discussions, and you are a contributor. That's great. So it's not always about code. So this is just shows like the numbers, and something interesting that you can extract from Git and other sources is also like trying to see the growth over time. So here, basically looking at how many contributors are active each month since the project has started. So obviously that does not show the 2,000 number. This is, if you look at a per month basis, first we have growth or constant growth, which is really great. And if you look at like the last month, we have in the last month over 200 people active working on the project, which is also a good number. And that actually correlates and it corresponds also to the number of commits going into the tree. So it's nice to see that these two graphs actually align. Which, then you'll start thinking, who are these 200 people, and are they, is that the same number of people going, you know, and just more people are joining the same number or a core team, or how, or does that change in a dramatic way over time, etc. And that's where I wanted to look and see and understand, because it's very important that when you run a project like that, to see, you know, what's happening, who's actually running the project, and who's loyal to the project, and who sticks around, right? So if you look at this graph, you will see, for example, that, you know, we have like almost 100 contributors who worked two or more years on the project. We have like 50 of them who have been working on a project more than 3 years. So, and the blue section here which is the majority of contributors, are people who actually worked less than a year on the project. So that shows that there are there's a core, you know, contributor block, and there are a lot of people who come and go all the time. And that actually can also be seen in terms of commits. So basically, we see that, you know, we have the majority, like 1,800 or something like that, with 1 to 10 commits, and then a very small number, like with commits that go into the thousands. And probably, I mean, if you look around, I mean, some of the top, you know, committers in the project, you would find them in this conference usually, yeah, because they have been there for a while and they are very involved and so on, yeah. So basically, it shows that the way the project is done, I mean, we always have new faces, we always have new contributors, also new ideas and new code coming in, and it's not like the same core dictating or managing the project in a way that is not subject to change and so on. So there are new faces, new ideas all the time, which is really great. With that, I will jump to something else, which, I mean, many of you probably haven't seen before, because although it was available, or we have been looking at and working on for a while, it was not public, in terms of like, it was not published for everyone to see. And that's performance tracking. In this case, over 1 year. That's something we did like a little bit retroactively. This is now available. I will show the link later. This, you know, I mean, obviously you need to understand what that is. We have a test or a benchmark in the Zephyr tree called latency measure, which does actually go and test like key metrics like context switching, semaphore taking and giving, with mutex, heap, memory allocation, and so on and so on. And there are also different variants of this benchmark. So this one I'm showing here is like the most basic configuration. You can enable user space, then you can see also you know, numbers with regard to, you know, context switching between user and kernel threads and so on, yeah. And obviously, immediately you will notice that there are like big jumps in the graph there. In this case, these numbers are going down, yeah, which is you know, not bad, yeah. But you also see a lot of things happening there as well. Okay, for example, this is actually very recent, early March. And I saw that and said, oh, okay, that's, you know, suspicious. What's going on here? And one thing that you can do here is go and bisect and see what happened here. Is it justified? Is it my script? And so on. And I bisected that, and that's a commit that introduced that. That was me, yeah? So I was not happy about that. And I had to go and look and see what exactly happened there. And if you look at the commit message, this was no functional change. I was just moving things around, trying to clean up the tree. And, you know, talking with Peter, one of the kernel maintainers, and looking also at the change itself, at the commit, I immediately noticed that, I mean, okay, I moved I mean, we had a lot of functions, a lot of functionality, or a lot of the implementation in one single file in the kernel. This is the scheduler. And a lot of things were, I mean, basically declared static inline. And when you start moving things around, you would assume the compiler would take care of everything, etc., but that's not the case. That, by the way, the bump or the change is actually very minimal. We are talking about 500 nanoseconds or something like that. And by the way, this is using Chemo. Yeah, so this is using Chemo. I'm not even trying to use hardware here. And we established, or by running the data on all the emulators, some emulators are a little bit, they go up and down in a crazy way. But some of them are actually really stable, Chemo and other simulators. And I'm not interested in saying here, or seeing like speeds, or like trying to meet a criteria, or like certain numbers. I just want these simulators to be stable. So if I run them on a code from 1 year ago, and now, I should see basically the same trends, and not things going up and down like crazy. And that this is like a RISC-V Chemo, I think. And you can see there. And by the way, so I actually went and moved things around a little, put like some of the functions, which are utility functions, in a header, moved it and submitted a pull request. Interestingly, my fix for this problem improved the performance and brought the numbers, or made it better than before this commit. So something, actually at the end, a net gain of 500 nanoseconds after the fix here, which is really great. So this is one. There are, this is also part of the dashboard. We are using Elasticsearch, and this shows you the difference that we have basically from, I did it like on a weekly basis. So from week to week, like every week since last year, I would go and run the benchmarks, and you will see like this shows the difference from the last value. So it would immediately show you, for example, where certain changes have happened. And over the last year, you will see that there are fluctuations, but these are like very minimal. We are talking about a few nanoseconds here and there. This is like, you add like one line of code probably in some function in the kernel, to fix a bug or to improve something, and that would show up here. Yeah, this is how sensitive it is. However, we also noticed like major changes there. This one can be contributed to this guy here. Yeah, this is the drop, which is actually a positive thing. This is when we move to Picolipsy. Yeah, and this is the memory allocation. I think the heap something, I don't remember right now, but this actually is one of them. And if you remember, we also had this, we have seen the same thing in the footprint. Yeah, I will be showing that. But this is like one of the things that came out of the Picolipsy, making Picolipsy the default. Yeah. And there is a few others that I will be talking about as well. So here, that's basically one of the tests that we have. It's the kernel abort kernel from kernel. And you will see that this is like a step function. One change happened in November, and the other one was in early March. I bisected. The first change was introduced by Peter Metzes, one of the kernel maintainers. And I looked at the change. I mean, this was like really a functional change, a bug fix mostly. I mean, adding and moving things around. So a change in the metric would have been expected, and I don't see that as a regression in this case. Yeah, I mean, looking at like all of the code that was added, the branching, the conditionals, etc., that is something that is really expected. The other one is actually the same commit that I was talking about earlier. Yeah, so actually with my fix, this actually will go a little bit down as well. So I mean, the net change there is something minimal and acceptable. Yeah. Now going back to, this is performance, and I'm just showing like one aspect of that. If you look at footprint, which we have been tracking actually for longer, and it's also public and available on stats.zephyrproject.org. Something that we want to move to the same infrastructure we use right now using Elasticsearch and Kibana. And you will see, actually, it's over time. And by the way, this is on Freedom Board, like one of our earliest boards that we have in the tree. We have a few applications, like here, the footprints. This is a footprint application, and here it's using user space. So different configuration to see basically what's going on. And over the years, since like almost 2 years, it's actually not bad. It's going down like on a constant basis, yeah? And a major drop happened when we introduced Picolipsy as well, yeah? So it has major impact on the footprint in a positive way. But we keep seeing like drops whenever we optimize or overhaul the code and so on. So it is definitely going in the right direction. This is not an exact science after all. I mean, sometimes, you know, a K-config is dropped. Sometimes you might be actually dropping like one feature here and there. So it's not always the code being optimized, the same code. Sometimes things go away, but at least this will give you a trend. And the way it is done, so it's not like just like an image number. It actually goes by the, you know, by the components that you have in the binary. So you have the kernel, you have, you know, the subsystems and so on. Actually, and now we are looking into going deeper, because some of the subsystems like Bluetooth or networking are so big, and the maintainers of these areas want to zoom in basically and look at their own subsystem so they can optimize at the subsystem level. So we are working on adding additional layers so people can see exactly where, for example, in the Bluetooth stack, they can improve or how they can track the footprint there. Another one, basically also related, coming from the footprint. This is without user space, and the drop at the end there, I think that was last year in August or something like that. That's also related to the Picolipsy change, yeah? If I see that correctly, yeah. Okay, so this is like footprint and performance. So all of this is available online. It's actually being tracked and updated on a daily basis. The benchmarks, it is online, and I need just to submit like this. We need to submit the CI change to start tracking that on constant basis. And now this is all great, and it is, you know, very useful. However, there are other things. I'm trying to move to the next slide. Did I freeze or what? Okay. Slideshow. Okay. Let me go back. Okay. So beside the social stuff and number of commits and contributors and the performance and footprint and so on, we also try to track things that relate to our day-to-day work and operation of the project. And one thing that we started late last year, earlier this year, is tracking like the merge criteria, making sure that we keep, I mean, we keep ourselves honest toward the community and toward, you know, our colleagues in the project, and try to be consistent in how you know, pull requests and changes are processed and dealt with. So this is something like part of our guidelines and documentation, is that we have some criteria defined for merging a pull request. So for example, needs to have a minimum of 2 approvals, including an approval by the designated assignee. That means that the maintainer of the area that is being changed. We have the 4I principle on the organization level. That means if the submitter, the reviewers, the assignee are from the same company or organization, the merger needs to be from a different organization. Yeah? And that's just to make sure that things are played in a fair way and things are not rushed into the tree by one organization. And then a minimum review of period of 2 business days, 4 hours for trivial changes. And hotfixes can always be met. So I mean, this is something that at least most of these things can be tracked and can be accounted for using scripting and so on. The 4 I's principle, this is something that we are still working on. So we are monitoring that manually. But based on this criteria, we actually provided this here, provided by Fabio from Google. It's like a merge list to make it easy for people with the merge rights to actually go and look at what is ready to be merged. And that actually has been working really well. Almost we have been using that for 2-3 months. And it had helped a lot with how we deal with pull requests and how we merge things. And we got a lot of feedback last year in the developer survey and also in the conference ZDS in Prague. And since then, we really got a lot of, we made a lot of progress, and a lot of people are happy with how is it working. Just to show you an example, this is a dashboard we created to track basically also any pull request that is merged, basically tracking who merged that, who was the submitter, and so on. And it has helped us identifying trends. And and with when you start using also the merge queue or the merge list, everything is transparent. People can see exactly what's happening over time and who is leading the charts in terms of merges and who is leading the charts in terms of submitting pull requests and so on. So it gives us like an idea and see exactly how things are going. But it also shows us if we are violating our own rules. And this is the example here. So we have like 2 pie charts. And this is, I think, over, the first one is like 2003. It shows you like assignee approved. No is almost 15%, which is not really great because that means we have merged something that was not approved by a certain assignee. It's not always bad because sometimes there are exceptions, but 15%, that's way too much. That means we are doing something wrong. Either things are being assigned to the wrong people or assignees or maintainers are not being responsive and so on and so on. The other pie chart is showing, pull requests that have been merged with giving enough time, for people to review. 60% yes, and no, almost 40%. That's not really great because that means we are rushing things in, sometimes not giving people enough time to review. Yeah. So this is 2023. Yeah. If you look at 2024, and we started like I think in February to start enforce and getting accustomed to the dashboards and then use script and the merge list, that number actually went down. Yeah. So at least for the assignee approved, you will see that NA means there was no need for this, or there was no assignee because this area doesn't have a maintainer and so on. Yeah. But the number in red here, that's basically a major improvement from 2023. Similar thing with the review time. So that means that we went down from almost 40% to 10%, which is really great. That means we have enough time, we given people enough time to review things. If you look at like just last month, that's even better, right? So we have been like really doing well on both fronts, and I would assume like even like these, the things that did not go or did not follow the criteria probably were just exceptions for whatever reason. I mean, our scripts, after all, are not that perfect, and sometimes you have the wrong label or the wrong assignee and stuff like that. So we have been doing really well. Just going, I mean, on other dashboards and other data that we use is like we have the code coverage, something that we run also on a constant basis. Every time we push the tree, I mean, using at least the tools that we have and the capabilities that we have, we are able to extract coverage information for basic functionality. Yeah? So it's not every feature that we have in the tree, anything that we can run in CI. We have our own dashboards for tracking bugs and issues, and something that we use on a daily basis, basically, or on a weekly basis when we do the triaging, so and how many high priority, medium priority bugs, and so on. And we also have static coding analysis charts and data that comes from Coverity in this case, and does not really, it's not something that we produce, but we at least do the scanning, submit to Coverity, at least the open source side of Coverity. And we get like, because we have been doing that for a while, we can get like some data about, the type of issues that are found in Coverity and so on. So that's really great as well. So there are many places where we actually can collect data. But that's not great because this is like all over the place. And we are trying basically to consolidate and gather all the data in one dashboard or one place. Ideally, this would be Kibana, Zephyr which is our Elasticsearch instance. We want also to try and create a feedback loop so that, like, if there are anomalies and if there are major drops in performance, or even if there are positive how do you call it, improvements, yeah, then we want to know this. It shouldn't be that, somebody should be watching these things. So we need to figure out how to get notified when something happens so we can, respond immediately. We want also to identify issues as early as possible. So right now we do it on the tree, on the checked in code. We want to have certain checks run on pull requests. So if somebody increases the footprint, they should know about it. Or if their change decreases the performance of the kernel, context switching, or other metrics and so on, they need to see that so that we don't merge the code and fix it later. We can react to it as soon as possible. And we want to obviously to add more metrics using hardware, because a lot of the things that we have depend like on simulators and stuff like that. And it's very important that we also see how things work in real life. So we are looking like at using, for example, tracking timer accuracy using also logic analyzers and other external tooling. We want to go further and look at various subsystems, whether it's peripherals, whether it's networking, Bluetooth, and so on. Yeah. So we definitely want to increase that and try to have everything in one place, which would definitely improve the overall quality of the project. So key takeaways here is that tracking helps with enforcement of project principles and guidelines. Yeah, this is like in terms of footprint, in terms of the merge time, and so on and so on. Yeah, visualization of project activity provides an early and transparent alarm system available to all stakeholders. It is key. I mean, a lot of these charts, sometimes you create them, you look at them yourself. It's fun and so on, but I think the most important thing is whatever we do here is available to everyone exactly the same way and exactly using the same infrastructure, so that more people can first contribute with additional metrics, but also so we can have people analyze and look at the data and come up with solution whether it's technical metrics or even like things that are related to how the project operates. Yeah. These are the resources, so GitHub Insights. All of you are familiar with that. LFX Insights, it's insights.linuxfoundation.org. And I will actually show that briefly because it's actually really nice. I hope I can do this in the last few minutes. So here, this is, okay, so this is, and it's, oh, okay, I can look here. That's good. Let me start with this. So this is the metric stuff. As you can see, you can select the platform that you want to choose. Some of them are really flaky in terms of you can have multiple platforms, then it looks really weird, yeah, because they are on a completely different scale, yeah. So usually you would actually want to go and select one. And you can, this is the difference here. And you can go and look at the metrics one by one here, yeah? So that's something that you definitely need to go drill down and play with the numbers and so on. But I think this guy here helps a lot identify when major changes have happened. And you can actually also select which metric you want to show. So here, like, oh, I'm interested in FIFO blocking kernel to kernel. You can do that. And you can see exactly what's going on here. So this is one. This is the dashboard that we use to show that to track the merge criteria. This is like the last 30 days. Shows you exactly who's active, who's merging, who's submitting, top submitters, top reviewers, and you can actually go and and select also like a name, in this case here myself, and see basically what this guy is going and who's merging their pull request and so on. It is really provides some transparency on how we are dealing with our community and code changes. So that's that. This one just shows like the bugs, high priority, medium priority, etc. Goes back to 2019. No surprises here. I mean, the numbers go up and then go down. I mean, this is when we triage them probably, and it's like a constant curve if you want, yeah. This one is the footprint. You can go in and select which application. So we have a lot of Bluetooth application here. We also have a lot of example platforms because different architectures behave differently. You can also, beside Flash, you can also look at RAM. So RAM actually doesn't change much. This is like stack and stuff like this. So it's steady. A lot of the changes usually and fluctuations happen on the footprint side. On the Flash side. Here, this is Coverity, yeah. But that one, LFX Insights, that's actually really interesting because you have to be careful when you look at the data and read exactly what each metrics means. And that's actually very well explained in the pop-up here. But it actually goes into a lot of things related to open source projects. So it goes into issues, pull requests, forks, stars, etc. And it's really nice sometimes to see where are you standing and if you are doing well and so on, or if your company is contributing enough and so on. Yeah. So that's really great resource as well. Take a look at that and yeah, play with this. There's a lot of data. Yeah. With this, thank you everyone, and if you have any questions, I'll be happy to answer them. Wow, right on time. That's good.
Yeah, I've tried to go to these provided links like stats zephyrproject.org and Kibana zephyrprojects.io. And in my case, I don't see anything statistic. Like in case of Grafana, it's just default Grafana page without anything. In case of Kibana, I try to go as an unlocked user, and again, I see no data at all. Do I need to be in some specific group?
No, it should be anonymous. We can take a look at that after that. Maybe it doesn't work on your mobile or something like that. But
yeah, it could
we'll figure
be,
it out. Yeah.
Okay.
They are anonymous, yeah, so it should be fine.
If I develop application or drivers out of 3, Would it be possible to replicate some of these dashboards, specifically around code health, locally or in an environment?
Yeah, so for example, the benchmark stuff is something that you can run in the tree on any board, on any driver, on any hardware. Yeah, so it's actually, this is code that is available in the tree. Same thing with the footprint analysis. All of this data is based on scripts and tools that we have in the tree already. We just collect it in a certain way and push it, to these. Obviously, if you want to visualize and so on, you can do that also using Excel or whatever, right? I mean, you don't need to use these tools. Yeah.
Okay, thank you.
You didn't mention about test results, about tests that can be executed on board farms. Are there any plans to make this public? Or?
Well, I mean, the data is there. Yeah. So, I mean, if you go there, but that's like a testing, where is it here? That's, I didn't look there for a while. So excuse me if that, no, actually it's working well. Yeah. So last 7 days. So if anything that we push into Zephyr, when we run the test, we actually publish the results, all of the chemo results and so on. Yeah. So all of that is also being published. It's also public. We want, as you mentioned, to actually establish something like this also, like for hardware farms, so like different users and vendors can push the actual results of tests running on their hardware into one common place. And that's something that is in the works right now. Right now, all of the data that you see here, which you can access anonymously, is based on chemo. Yeah. And that just gives us an idea of, how many bushes and how many architectures and how many platforms, how many tests, which areas are covered most. We will see here like the kernel, libraries, logging, etc. But you will also see that certain areas are not really covered. And I'm talking here about running tests that are actually run and not just built like on platforms. So a lot of coverage we are getting using native POSIX and chemo. And a lot of features that are not testable in emulators will not show up here. Yeah, and that's really bad. And hopefully this will change in the future once we start running on hardware. Yeah.
So what I'd like to see a little bit more like statistical porn, specifically about, for example, tests which we run in upstream CI, to see how we are first growing number of tests which we execute and maybe different configurations, because for me it's interesting how it could be sold to somebody saying, okay, so you may measure coverage in different ways, but if we are growing the amount of tests and we growing the amount of platforms and architectures, so then you also see what amount of background work is being done actually. So for each PR, how many things you check and test and everything. So that is one thing.
That's exactly what you see here. Yeah, I mean, like 2,600 test suites, 20,000 test cases. Platforms 1,000. 1,000. By the way, this is because of the hardware model V2, because now we have like old platforms that have new names, and in the database they appear as new names. Okay, so this is.
So can you plot these platforms on a graph to see how it evolves with time?
Yeah. There are different ways to display this. By the way, here, for example, you see like which platforms are executing most of the tests. And Native Simulator right now is leading the pack. Yeah. Chemo x86 as well, because that's where we do like user space testing. Unfortunately, that does not appear here, but there are, it would be really great, like if we can also, for example, from Synopsys, we could run NSYM somewhere, right? We do that. I have access to that. There is ways to start publishing this data here as well, because in the performance, I had NSYM as well. Yeah, so that's, which I liked really much because it's very predictable, very deterministic. Yeah, which you can use as a reference. But I didn't choose to use it because it changed names, in the last month. So that would skew the graphs. Anyways, yeah.
Okay, thank you.
Thank you. Any other questions?
There may be last question.
Okay.
So yeah, great to see basically the compliance with our policies on the merge policies. But what was the impact overall to like merge times?
In terms of
Yeah. So yeah, like what's happening with our just overall PR merge times? Like, is that,
I mean,
I know that's something that Benjamin's been tracking as well. So
yeah. I mean, it's not like we are deteriorating or it's becoming worse. I mean, I think it was really bad that we were merging too fast. Yeah. And right now, there is at least a checkpoint or like a way to see, okay, this PR is ready to be merged because it was reviewed enough based on our criteria. It was reviewed by the right people. There's the assignee has approved, etc. And you see it in one place, so there is no doubt that hey, I can merge it or not. Sometimes because people didn't just want to start calculating times and so on, or they were nervous about merging something. Now we have something that would give us like some assurance that hey, this is good to go. That doesn't mean that you just go and click and merge it. Sometimes you have to go as a release engineer and spend some time and figure out, okay, maybe I need to add another review, or maybe I can't merge it because I am in the same organization and so on. But in general, we are around these like 2 days, 3 days for pull requests that are ready to be merged, which is really great. Yeah. Last question.
Thanks. So you mentioned about like showing these benchmarks and that. So I often realize that there's a case that people ask you to like, let's create me some dashboard because it'd be super interesting, but then in the end, no one is looking at it. And I think that's what you mentioned, like with this benchmark, that you are looking at it and trying to identify the peaks and when it happened. And you also mentioned that you are looking in a ways how to automatize it and basically doing some kind of alerting system. Can you give some insight into it?
Not yet. That's something that we want to have. I still didn't look in a way how to do it. This could be used like these systems, like Elasticsearch or Kibana, but it can also be done in different ways outside. We need to see how it can be done. Yeah, I don't have a solution. Yeah.
Okay, thank you.
Thank you.
Okay, thank you everyone.